Hello YouTube, RJ. Hey, we're back on the jukebox today. Got a few things to go over with you. What's happened, where we're at, what's going on. So I went ahead and tested tubes, and I found that the 54UG tube for the amplifier was dead. The filament wouldn't light. Put it on the tester, wouldn't heat up, didn't do anything. Acted like it had an open filament. So I went ahead and put an ohm meter on it, and sure as the world, the filament was open. And so I went ahead and got one of those. I also went ahead and tested other tubes, and you'd be surprised at how many tubes I found that were bad in this amplifier. I think only one side was working. Had some shorted tubes, which made me nervous for these output transformers. I was afraid we might have popped one of those. Anyway, I went ahead and got a rectifier tube ordered. I went ahead and put an ohm meter on all the windings, and they all appeared okay. I expected I'd have an open winding if there was a problem. This one and this one pretty close to readings on each filament, or on each winding, so I felt confident they were okay. A little worried about the power supply because remember we did have a blow fuse in this unit. So I went ahead, ohmed out this. Primary looked good. The secondaries had minor resistance, a little bit of resistance, a few ohms, weren't open. Felt secure we would be good. So went ahead and got the tube coming, went ahead and ordered the other tubes. This one has come in. I went ahead and tested on the tester. Unlike the other one, tests perfect. Put it in, made up some cords to interconnect between these units. That's what you're seeing here. You get filament power from the Tormat selector unit. So I've had to create a jumper right here to bring it over to this side. And then you also get 120 volts from here, but on the bench, the problem you have is this will not supply 120 volts until the other control unit sends a play signal saying, I'm going to play. Because what it does, the amplifier filaments, the reason they did it that way, it seems kind of crazy. And let me move you just a little here. I'm sorry for moving you, but you can see the jumpers I'm talking about. Okay, what happens is they control, basically what you have is this plug on the side of the TSU. The TSU plugs in. It's the only one with a power cord. The first set on this side over here, up and down, gives you 120 volts plugged into the males over here on this side. But it only does that when the TSU unit gets told, I'm going to play a record now. On the other hand, the filament power from the transformer on this is fed anytime the Tormat unit is on, is sent over to this unit for the 6.3 volts to warm the tubes up. Now that seems kind of crazy why they did that way. They've got their own power transformer over here. Why didn't they just have a 6.3 and whatever voltage winding and whatever they need and do that? But the reason is this. These things are jukeboxes that sit in juke joints, and they may sit there all day long and only play a couple records. So there was long periods between playing. So what happens is the tubes take time to warm up. They take too long. If you were to make a selection on the jukebox to play a song, it'll kick a record in too quick, and this would not have time. The amplifier would not have time for the tubes to warm up. So you can't leave it without power. So it feeds full time 6.3 over and keeps the tubes warmed up all the time, but it doesn't supply high voltage. So the 120 doesn't come across till you're ready to play. So the tubes aren't running hard, using a lot of power, generating a lot of heat. They're warmed up, but that's it. The filaments are running. They're warmed up, ready to go. So when you come in and it's been sitting there for 4 hours in the juke joint, not playing anything, and you push a selection, in the second or so, 2 seconds it takes to load the record, this thing turns 120 volts on. It's already ready to go. It's warmed up. It's ready to go. And say it takes 3 seconds to get the record loaded on. Boom. This thing is good to go. So that's why they did that. They didn't want this thing sitting here with high voltage all the time. So I'm telling you this to explain that you notice I'm not jumpering from here because this unit's not hooked up to the rest of the equipment. So for the bench, what I'm doing is I'm bringing just the 6.3 from here over to run my filaments. And I've built another cord that runs over with a power plug on it that hooks up to the isolated transformer and such. So it's all running off the isolated transformer and the variac over on the other bench. But I'm directly sending the 120 here, or whatever the variac's set to. This one gets it also, but this feeds the 6.3 over. So now that you understand the setup a little better, I can explain. So I got this set up, I put the tube in, I fired it up, and you have a test socket up here that lets you test voltages from above, which is very handy. They did it for their technicians to be able to work on these things without disassembling them. So I fired it up. I was very excited to finally see high voltage out of this thing. I fired it up, and lo and behold, well, we'll do it. I went ahead and did it, and lo and behold, I'm bringing it up. We're at 20 volts. I'm bringing the power up slowly. Current's looking okay. I'm at 70 volts. I'm at 80 volts. I'm at 90 volts. I'm at about 115 volts right now. And as you could probably make out over here, I've got a whopping 0.03 volts for high voltage when I should be getting around plus 365. Now that would be if all the tubes are in. It would be higher. It should be higher than that right now. I'm not drawing current. So I don't have any high voltage. So now I'm at that point. So I decided to kick the camera on, start getting some video, talk about troubleshooting and what I find and what I'm doing. And so we're going to go from there. So I'm at this point going to get everything turned over, start doing some probing. I'm a little concerned, and the reason I'm concerned is because when I look at the schematic, I failed to tell you the important part. This tube's not warming up. I know the filament in this one's good. It's not warming up. So I'm afraid this is blown. We probably have no high voltage filament, no filament heat or power, no high voltage. So I'm going to flip this over, get the meter, get it powered back up, start looking at what we got. I'll come back and fill you in on what's going on, and we'll move to the next step. See if that's the problem, or maybe there's something else going on. Maybe the fuse is not actually conducting. I'm not getting 120 volts here. So I'll be back when I can tell you more about it, okay? Okay, so here's what I've done. Pulled the manual back out. Look at that schematic here, exactly how it all works. And I got to thinking before I flip this over and mess around with it, I can do a lot of the testing right here, because once I pull the 5U4 out, I've got access to the pins of the socket. So looking at it, if you look here, I put my meter on AC because we're going to be looking at AC. Your filament, there's a winding coming off of that power transformer, two yellows that come over and directly go to the filament. So the question is, are we getting or actually it'd be around 5 volts. They're looking for about 5 volts with this tube. So that should be about 5 volts. So let's see. That's going to be on, hey, it's hard to read. These manuals have been photocopied to produce so many times that they're kind of hard to read. So I'm looking at 2 and 8. High voltage is 4 and 6. So 2 and 8. So if we go over here and look, we start here, we go 1, that should be 2 there. There's 2, 3, 4, 5, 6, 7. So 2 and 8 should be right there. So what we would expect is if I turn on the power, start getting some AC voltage. Now it popped up to about 0.6 volts. Let's bring the voltage up and see what I get. I don't think that's going to run a filament, because obviously, you know, this is high impedance meter. It's not putting any load. I'm not getting filament. That's not good. We're not getting filament. Kill the power. So my next question would be, am I getting high voltage out of this filament, or are they both popped? 4 and 6. Let's see. 4 and 6. Now, I'm going to turn the voltage way down again. Oh yeah, I'm getting 400 volts and I'm not putting but 50 volts in. We're getting high voltage, that's not a problem. That's at 50 volts AC going in. Let's turn it down some. It's making high voltage AC, no problem. So, interesting. So we know that we have this winding is intact, and we're getting high voltage to the rectifier plates, but we're getting no filament. And so therefore there'll be no conduction here to get us our high voltage over to this inductor that feeds all the high voltages to the tubes. That leaves me in a problem, because these transformers, they're probably not unobtainium, but they're darn close to unobtainium. I know there's some places that carry some of them for some of these jukeboxes, and I know they run $200, $300. Let me think about this a minute. I'll come back and I'm going to jump online and see if any of these transformers are available and how much they are, and give this some thought. So I'll be back. Okay, well, after some thinking and looking at the schematic, I came up with a plan, and I'm doing that. Now, this has been a couple days because I had to wait on a part to come in, which we'll talk about in a minute. Something I didn't have. Let me adjust the brightness of the camera a little, get a little more contrast maybe for. Okay, let's look at the schematic and talk about it. Now, we've lost this filament winding. And so what happens is this goes to ground here, this circuit here. So what happens is you get your current for your high voltage from the filament conducted from the plates. And what happens is, since a tube will only conduct one way, basically the original tubes were just diodes. They were the great-grandfather of the diode, if you will. What's happening here is you've got AC back and forth that's being rectified with the rectifier tube into DC. That's all the tube's doing. If we lost the high voltage winding, we would be done. We'd have to get a transformer, and I still haven't guaranteed that I found one, even if I wanted to buy one, and I am looking at quite a bit of money. So, but thinking about it here, if I was to do away with the 5U4 and convert to silicon diodes for halfway rectification, I don't need filament heating. I don't need a filament to heat up. So this wouldn't matter that it's gone. Instead, I could just take off of the high voltage plates with diodes to this line and get my high voltage. And this is commonly done. In fact, they make units you can plug in and do this, but you don't really need these the fancy little thing. They do that so they can go back and forth if they want to keep swapping. In this case, we would just do away with the tube. I think I'll probably put the tube back in. I've done it up to where I can put the tube back in for looks, but it won't heat up and it'll just be there. So what I've done is pin 6 here, I've disconnected both filament winding connections to the socket. I'll show you in a second. And I've shrink wrapped them off to keep them safe, make them safe. And what I've done is taken from 4 and 6, this is 2 and 8. 4 and 6, I've taken diodes, and I did a little drawing up here so I could show you, and I did it before I did it to keep myself straight so I wouldn't screw up. But here's pin 2, here's pin 4 and 6. I've taken two 1N4 001, or I'm sorry, 007 diodes and put them series back to back around a 2. And what this has done is allows this to do the rectification. The current flows through and gets rectified. Now, why did I do 2? Because the ratings on these are 1,000 volts, and these units are pretty high voltages. And so I felt like that probably would be fine at 1,000, but by putting them in series, I can take advantage of the 1,000 for each one of them. You're going to be able to handle more current this way. I mean, and more voltage this way. So this makes me very comfortable. I'm not worried about drop because that's the next thing we're going to talk about. The 5U4 drops a lot of voltage. They claim like 50 volts at max current, which obviously this doesn't run at max current, but I mean, we're talking a substantial amount of voltage being dropped across it. That's why the 5U4 rectifier tubes and the other rectifier tubes get so hot. There's so much drop across them. So I don't have that with a diode. You know, at best, what do you got? 0.7 volt each. This will work fine with one caveat. The high voltage coming out of that is going to be probably 40 volts higher than the original circuit. That's probably okay. People put those units you buy in and run amps all day long with them that way forever, but it makes me a little uncomfortable. Now, I did replace all the caps. They are new. They are higher voltage, most of them, but I still feel uncomfortable running something at a higher voltage than it's intended to be. So I'd like to try to get it down. If it can't get it down to where it was, at least get it much closer. So here's what I've done. That's where I had to wait a couple days to do this video, because I had to jump online and find a resistor that would get the job done for me. By my estimates and doing a little research, 200 ohms will drop the voltage very similar to the 5U4. I should put me right in the same ballpark. But the problem is it drops a lot of voltage doing that and generates a lot of heat. Online, people were talking about using 25 watt. That probably was fine. I went 50. It might have cost $2 more, but I know this thing will not burn up on me. So that's what we're doing. Now we're going to put this in from here, and that's going to get us our high voltage. This is going to drop the resistor is going to drop the extra voltage, and that's going to solve the problem. So here's what it looks like. Let me get the book out of the way. Here's what it looks like. You can see the 4 diodes in series coming from the high voltages over to this pin, which runs into the inductor, which that wire runs down through the chassis to the transformer on the top, which is actually an inductor. So what I'm going to do now is take this lead loose. I'm going to mount this resistor over in here, and I was going to drill and put screws, but I realized I can get this in here on that stud of that transformer. If I just open this hole up some, so that's what the drill bit's for. I'm going to drill this, take this nut off, bolt this down. That allows this to not only use its normal heat sink, but to use the chassis as a heat sink. Drop this in, bring the wires over, connect, shrink wrap it on there, and that's going to be that. And then we can test the high voltage and see where we are. Now, we'll have to put tubes in to see where we really are to get some current draw, but our tubes have come in, so we're ready for that. I need to get this in. I can pop tubes in. We can power it up. We can see how our high voltages are going, and we can find out if this amp works. Because at this point, I've done everything. If I get high voltage at this point, I know there's power for the heating elements in the filaments in the tubes. I know that's there. Just got to get the tubes in after we do this, and we can see if this amp will work. So hopefully we're going to find out if we've got this monster working. I'll be back as soon as I get this resistor drilled and get it mounted, and we'll go from there. All right, with that, I've got that resistor mounted in here. Take a new wire on here, shrink wrapped it, double shrink wrapped it, brought it over, connected it to pick up the high voltage after being rectified by these diodes. Runs through the resistor, dropping the extra voltage. Everything's out of the way, nothing's touching it. Again, out of here, I'm going to bend that wire just a little bit. Here. Get a little pressure off that wire. I don't want to rub it on that transformer like that. There we go. Comes around, goes to our inductor. So high voltage comes out through the resistor to the inductor. We should be good. We're ready to turn this thing over. Ready to pop some tubes in, see what kind of power we get, whether we get our high voltage, get the high voltage in the range we expect. I know it probably will be a little high, being that we're probably not dropping as much, but we're going to be in the ballpark. I'm hoping to be under, say, 420. 420 or less, I'm going to be happy with all the tubes in. So give me a few minutes to get this flipped over, wired up, all the tubes in, and I'll come back before I do the test, and we'll see what we get. All right, we're back. I've got all the tubes in, got everything hooked back up. I went ahead and hooked the meter up for high voltage. Being optimistic, I went ahead and fired up my SigGen. I've got it set up for the lowest output I can put, 2 millivolt peak to peak at 1,000 hertz. That should be in the ballpark of what the magnetic cartridge, I think it says the max is about 3 volts peak to peak. I don't know how much the volume's turned up on this thing, and I know the tubes are very soft in it before, so I imagine wherever it is, it's probably loud. I probably should have turned it down, but we'll see. If I blow your eardrums out, I apologize now. I've got everything hooked up, and I'm not going to mess with trying to get into that volume control underneath. We don't even know if it's going to work. This is the inaugural test to find out. So here's what we're going to do. We're going to power up. We've got, what, 0.056 volts on the high voltage at this point. I've got the variac turned down very low, like 20 volts. Let's kick her on and see if we see anything. Wow, 100 volts already. Hopefully it doesn't. Okay, I'm going to start bringing it up. Now, until the tubes warm up, it's going to pull more. It's going to have higher voltage. What I'm looking for is at operational. It's supposed to be 365. I'm wanting to be under 420. 420 I know is not going to be a problem at all. So as long as we can keep her under that, we're above already. The tubes are warming up, and I'm basically at full voltage. So I'm a little higher, but it's coming down quick now that the tubes are coming online. Yeah, it's getting right down to where I want them. $395, it's a little high, well within my comfort zone, but of course it's still warming up. It may come down some yet. This is looking really good. I'm really happy because I know it would have been, you know, the guys are talking about when you do these changes and plug those in, often, you know, you're seeing like 20% voltage increase. So we'd have been 450 or, you know, it'd been pretty substantial voltage over, but we're falling 385, still coming down, well in my comfort range. We're only about 20 volts over at this point. Okay, I can hear. I don't know if you can hear. I'm going to take my mic off. You hear some rustling. I'm sorry. I'm taking my wireless mic off. Put it by the speaker. Close enough to make sure. I don't know if y'all can hear it or not. It's making the light white noise that you typically have in these amps when they're on with the audio fed to them. So I'm going to put my mic back on, and I've got a probe stuck into the audio input of one channel, and signal to grounded. I just moved the ground a little and it popped, so I think we got something going. So I'm going to touch the input. We should get that old 60 hertz hum you hear. Oh yeah. Let me move to the other channel. Oh yeah. Oh yeah, we're getting audio. I think we're working. All right, hopefully we don't blow our eardrums off. Here I am. I'm going to kick on for the first channel. This will be the right channel. I'm going to kick on the audio feed in the SIGGEN. All right. That sounded pretty good. Let me jump over the other feed. I'm going to kick it on. Oh, it wasn't touching. My little probe, my little pin wasn't making. There we are. Now that speaker's facing towards me, so it's a lot louder. The other one's facing away from me, just the way I had to lay them in the chair. You can't even power these units up, by the way, just an important note, until you plug the speaker jack in, because it jumpers, and you don't want to power this thing up by jumpering it yourself. You need the load of the speakers. It's not good for those transformers and stuff. This is looking good. 382, we're supposed to have 365. We're under 20 volts high. It's sounding good. I'm ecstatic, guys. I'm absolutely ecstatic. We got her back alive. The only thing I got left to do is plug the 5U4 rectifier back in, just for the looks of it, if you will, and keep the holes closed. And this amp is ready to go back into the jukebox, but we're going to take it and put it on a table with all the other equipment and work on getting all the mechanicals working next. I've got TSU, got tested the tubes, got tubes appear to be good. There's a couple I couldn't. The OA2 tubes, the voltage rectifier tubes, I couldn't check, but I understand they're pretty reliable. You don't typically have any issues with them. They're a weird tube. Hopefully this thing is ready to go. All the tubes are glowing, looks good. So that's the next thing. First thing we're going to do is go down to the rec room where the jukebox is, and we're going to have all this set up on a table. We're going to clean all of the contacts on the other devices, like the coin payment box and all that. Get that all cleaned up and prepped. Hook all of it up. Find out if it works and start troubleshooting if it doesn't. Knock on wood, we're going to have a jukebox going here before too long. I'm very happy about getting the amp up and going. That was a big, big thing. Unfortunately, we had to spend quite a bit on tubes. I'll see you in the next video. Thank you for tuning in, guys. And if you haven't subscribed, if you do me a favor, go subscribe. Help the channel out. Give me a reason to keep making all this content. Catch you in the next one.